Section 7.1, exponential functions. An exponential function is literally the most useful function that we will have in mathematics. It is in the form of y is equal to a to the bx, and it is the most useful function because it is used for growth, decay, and money. We all want to know how well our money is going to grow. We all want to know what populations we have in our counties and things like that. Birth rates and decay rates, death rates, those are all what we use for exponential functions. Do we all understand that, yes or no? Visual or verbal, do we all get it? Okay, now, what does a growth model look like? A growth model is going to be when the x's increase, the y values increase. So as x gets bigger, my y values get bigger. Those are the ones that we want to have on our nice little money, our savings account, our lovely little checking accounts. We want all of those to be rising quickly and effectively. Okay? Decreasing, a decay model is whenever x increases, y decreases. An example of this would be the death rate in a certain country or in a county. Okay? There's a place, I think, over in Greece that their death rate is ridiculously small. And the reason why is because they use different type of diet over there. And basically what you're going to be looking at is the death rate is going to be smaller across compared to, let's say, compared to 1920s, because we have major strides in health industry, yes? So our health is able to stay better than it was in the 1920s. So therefore, we are going to have a very slow decay. Why is it decay? Because we're always dying, aren't we? From the minute that we're born, we're always dying. So that's why it's decay, okay? Now, today what we're going to be talking about is understanding the difference between a growth model and a decay model. I'm sorry?
You missed the word first.
It's okay, we'll come back to it. Okay, so this is our lovely little model that we're going to be using. Y is equal to a to the bx. A is always going to be greater than 1. Always. Okay? However, when b is greater than 1, it's a growth model. Always growth when it's greater than 1. When b is between 0 and 1 and it's a fraction, that fraction is going to represent decay, so therefore that's a decay model. Okay? The other value, which is the a right there, is going to be our y-intercept. Our y-intercept. It is the initial value. It's the initial amount you invested into your bank account. It's the initial amount of the population of deer someplace. It's the initial amount of fish in a pond. Okay? So a is always going to be the initial amount. Here's the formula that you have. A of t is equal to a parenthesis 1 plus r raised to the t. Now here's what I like to actually see. I like to put 1 plus or minus r. If I have the plus, that means I'm growing. If I have the minus, that means I am what? Decaying. Do we understand that? So your brain needs to understand the difference between that. You're either adding a percentage rate or you're subtracting a percentage rate. Growth means you're adding, minus means you're decay. Does that make sense, yes or no? Okay, so this formula is what we're going to be utilizing the entire time. Now, an example. Identify each function or situation as an example of an exponential growth or decay. So, the very first thing I need your brain to look at here is this 12. Your 12 is the initial value, which is also known as your y-intercept. So your y-intercept is the point 012. You with me? That's what you are going to write. Then you are going to be looking at your number that has the exponent. That is 0.95, and 0.95 is that greater than 1 or between 0 and 1? So that means this is a decay, and that is what we call the decay factor. That is what we call the decay factor. Does that make sense? Okay, next. Same exact philosophy here. I have my A value. What is my y-intercept then? 0, 0.25 is my y-intercept. That is the initial value or population or whatever you're measuring. Then I want to know if this is going to be a growth or decay. So is the number 2 greater than 1 or between 0 and 1? It is greater than 1, so since it's greater than 1, 2 is my growth factor. Does that make sense, yes or no? Okay, now let's look at the last example down here. The last example is going to be put into words, and it says, you put $1,000 into a college savings account for 4 years. So what's my initial?
1,000.
So what's my y-intercept? 0, 1,000 is my y-intercept. The account pays 5% annual interest. Am I growing or am I decaying? Your money is growing, so I need to know what my growth rate is. So how do I find my growth rate? My growth factor is going to be 100% of the money that I put in plus 5% annually to give me a total of what? 105%, and then we are going to get that out of percent, and our decimal is here, so we're going to move it to the left 2 units to give me what is my total growth factor? 1.05. Does that make sense? Okay? All right, let's keep on rolling. Number 3, I want you to come up with the equation and then with the amount. Everyone is going to need Desmos up on your calculator or on your computer, so make sure you have that pulled up as well. I'll give you like 30 seconds here to get that ready to go. All right, so everybody has Desmos up on their calculators, and here we go. You need to come up with the equation first, and the equation that we're talking about is this. A of t is our balance or our amount that we have in after so long. A is our initial amount. 1 plus or minus r is going to be our growth or decay factor, and t is going to be the time that is inside our lovely account. So it says you invested $1,000. What letter is that up there? The little a. So this is 1,000. And a savings account at the end of 6th grade. The account pays 5% interest. Is that growth or is that decay? Growth. So I know I have a 1% plus 5%. You are going to take this 5% and you're going to change it into a decimal. So what decimal is this 5% going to be? Put it over 2 units, so 0.05. And then it says how much money will be in the account after 6 years?
So 6 for the T.
6 for the T. So you are going to put into Desmos 1,000 parenthesis 1.05 close parenthesis to the 6th power. So we're going to come over here and we're going to do that. $1,000 parenthesis 1.05 raise up to the, what was the year?
6.
6? Was it 6?
And did that for the
how much money is in that account?
$1,340.
And?
95 cents.
No. And 10 cents. You have to round to the hundredths place. So 1340.10. Do we understand that? Yes or no? We good? Okay, again. Suppose you deposited $1,400 in a savings account that pays interest at an annual rate of 7%. Now, again, your brain needs to say that you're using this lovely little function. Is this growth or is this decay? Growth. So, what we actually are going to be having here is going to be my initial amount, which is what value? 1,400. And then I am growing 7%. So the 7% turns into what? 0.07. So this is 1.07. And then I want to know how much I have in my account after 20 years. Raised to the 20 power. Yes? So I come over to Desmos and I put 1,400. Parentheses 1.077.
On the outside of the parentheses.
You have an extra parenthesis.
It didn't like me. Raised to the 20. Oh, Judas. So, how much money will I have in my account now?
$5,417.36.
Yes? Does that make sense?
She's talking about.
All right, part B.
This year.
How many years will it take for the account to contain 2,500? This is where we're going to do a guess and check. So you're going to take the same formula and you're going to change that to that 20. So I'm going to come over here and I'm going to say, okay, let's go ahead and say 5 years. 5 years is not enough. Let's double that. 10 years. That's too much. Let's go down by 2. That's not enough. And let's go to 9. And what does it give you? The amount that we want. It had to be at least $2,500. So how many years did it take me to get at least $2,500? 9 years. And all we did was guess and check. Do we understand that, yes or no?
So do we have to really guess and check on them when we have any questions to show up?
Yes.
You literally have to take points off, you know.
An investment of $75,000 increases at a rate of 12.5% per year. 12.5%, that is great. And if you can ever get that, snag it. You won't unless you're in mutual funds. But still, that would be a great investment. So, immediately, I write my formula. Is this growth or decay? So 1 plus my rate raised to my t power. What is my initial investment? 75,000. 1 plus, what is the 12.5% going to turn into? 0.125 raised to the after 30 years. So 75,000 parenthesis 1.125 to the 30th power. And how much money do you have?
2,568,000.
2 million?
2,568,247.87
That's my kind of money right there. Could you retire on that?
cents.
You couldn't retire on $2.5 million?
Your retirement.
I could retire on $2.5 million. I wouldn't spend that. I'd be very happy. Do we understand that example? Okay, I'm going to stop right here and then we're going to start another one with your homework.